Hi, team. My name is Frank Wetzler, and I'm a senior member of the Boomi support team. And I'm here to walk you through how to solve a common problem that we see in support centering around low memory conditions, which our JVMs encounter when they're under significant load at times if they're not properly configured for that load. Um, in this example, we're going to take a look at a two-node molecule here. Each of these two nodes has a single JVM running on it, which is a very common configuration for molecules. And these nodes take all the load, whether it's scheduled executions or low latency real-time executions. At times, the load can be greater than the heap is able to handle within each JVM. And as a result, in the container logs, you will see what we call low memory warnings. These are low memory warnings. They look like this, where they outline how much memory is available to the JVM and how much is used. And once it crosses a certain threshold, it will show um, a low memory condition. So in this case here, I subjected the molecule to some significant load and it resulted in a low memory condition. If not addressed, what can happen typically is slower performance, or worst case scenario, you eventually end up in a situation where you've run out of heap space and the atom, that the JVM itself will shut down in those situations. Um, it's not ideal to run in low memory conditions because what happens is the JVM, or the code logic, starts to swap out um, the heap onto disk in order to prioritize running the execution completely instead of failing the execution. But what happens is, because of that swapping back and forth to disk, the execution itself can slow down. It also affects other operations within the JVM itself, such as communicating with other nodes and things of that nature. So if you sense a situation like that, executions running abnormally slow, or other situations affecting the performance of your runtime configuration, check the container logs for low memory warnings. Just search them for low memory. In this case, node 107, which is this node here, was running the executions and could not handle the scenario without going into, could not handle the load without going into a low memory condition. So the way to fix this typically is increase the heap. So in a molecule configuration, given that there's one JVM per node, typically in a non-forked execution scenario, molecules by default do not support forked execution. So the vast majority of molecules run with one JVM per node. The solution is to update the heap property, which you find under the atom management page. You look at the properties themselves, and this particular property is on the basic tab. And we see that here, the heap size here. So in this case, we'll increase it from 512 to 1024 meg. And then we save this. This updates the platform database with the new configuration. The head node of the molecule will pull that message down and update the Atom VM options file and restart the nodes. And then the heap will be increased from 512 to 1024. All right, I hope you found this helpful. Thanks again and good luck.